Thank you very
So,
much.
good morning, everyone. And as you said before, thank you for the presentation. This presentation is going to be about the influence of the binder on the susceptibility of the paint irradiated with a nanosecond pulse neodymium YAG laser at working at 1064 nanometers. And a bit of context. In the field of conservation of cultural heritage, cleaning is often required, as also we said in the previous presentation, and widely used is the laser ablation because of its advantages as selectivity, graduality, doesn't require a direct contact, and has a high precision. Also, we need to consider some drawbacks as photochemical alteration, the darkenings, or discoloration. And so advantages and drawbacks are need to be considered in respect of the integrity of the artworks, and we could work on some key parameters as the considering the properties of the treated materials as painting pigments, binders, and so on. And then on the other hand, we could consider the properties related to the laser. So the laser, it's acronym that stands for light amplification by stimulated emission of radiation, and has some fundamental parameters as wavelength, pulse duration, frequency, and fluence, which is the energy per unit area, which is we are going to consider in this work. So the general objective is the optimization of the nanosecond neodymium YAG laser working at 1064 nanometers to clean ancient paintings as tempera and fresco. So two specific objectives are the effect of the binder on the behavior of the paint under laser irradiation, considering the damage threshold fluence of the pigments and damage threshold of the painting. This same damage threshold fluence is going to be applied on the solid artificial samples, and the second specific objective is to evaluate the effect of the application of this fluence. So the used materials in this work are 6 different pigments previously analyzed and characterized as silicates, oxide, and sulfide. Realized the samples with 30-ton press to make them more handleable in this form as pellets. Also, these 6 pigments were applied in a painting mockups to simulate wall paintings, so with a substrate of riccio and intonaco, with 2 different binders depending of the painting techniques as tempera painting and fresco painting. Using in tempera painting a binder as egg yolk, and in a fresco painting slaked lime in water. Part of these samples were also contaminated by diesel soot, recollected from the exhaust pipe of car with diesel engine, and were submitted in a climatic chamber for 40 days, 18 Celsius degrees in the 80 relative humidity, and a contamination with gas SO2. And the laser applied in this case was a neodymium YAG in a quick switch mode with an active medium of aluminium garnet with lithium and doped with neodymium, which emit at fundamental wavelength at 1064 nanometers and a pulse duration of 6 nanoseconds. The irradiation methodology was subdivided in 3 stages. The first one was needed to determine the damage threshold fluence of the pigment only. Established considered 2 squares. The first one irradiated with a minus 10% of the fluence of the minimum damage, and the second one the minus 40% of the fluence of minimum damage. The best of these 2 was considered as the damage threshold fluence and was applied on the paint mockups. Evaluating the effect was determined also the threshold fluence of the tempera painting and fresco painting with the associated pigment, and also was realized another square with the intentional damage to be conscious of the effects in case of erroneous use of the laser. Then at the end, the third stages consists of the applying of the damage threshold of the paint mockups on soiled paints mockups. Evaluating the effect then was determined the necessary fluence for paint cleaning, applied with 1 and 2 scans to be more gradual with the cleaning. The analytic techniques applied in this case for the oldest stages were stereo microscope and color spectrophotometry, and then this spectroscopy was applied for the evaluation of the irradiated areas with the damage fluence and for the evaluation of the clinic effectiveness. So about the results, irradiating the just pigment pellets was possible to align a pigment susceptibility in which the silicates as green earth, Egyptian blue, and ultramarine blue were revealed to be the more resistant to laser radiation because we applied the higher fluences. Then the oxide were less resistant as the Mars red and chromium green, and at the end the sulfide was the more susceptible because even with the lowest fluences we had some darkenings. But even considering this condition, it was possible to identify edema threshold fluids for the cinnabar, confirmed by the colorimetric analysis in which the delta is lower than the threshold value, according to which on an experienced eye notice clear differences in color. And all these samples has this value lower than the threshold value, except for ultramarine, in which we have a higher value, and in this case was influenced by the luminosity component, which could be associated with the roughness. Applying the threshold fluences of the pigment on the painting samples, it was noticed a protective character of the binder because in almost all the samples contrasted in green was possible to increase the fluence, except for two, as the cinnabar in fresco, in which we needed to decrease the fluence because of a darkening, and the tempera painting with green earth, in which because of a whitening we also needed to decrease the fluence. So for the others, we see a greater protection given by the yolk for the most susceptible pigments as cinnabars and Mars red, and for the ultramarine blue. On the other hand, we have a greater protection given by calcite for the green pigments and Egyptian blue. All these values are confirmed by colorimetric analysis. Except for the samples, temporal samples with ultramarine blue and cinnabar, and for fresco with chromium green, in which we have higher values of the delta M, also in this case because of the influence of the luminosity component, which could be associated with the roughness. From the point of view of pigment susceptibility, silicates are still confirmed to be the most resistant to the laser radiation, and the sulfide is still the more susceptible. From the point of view of the damage fluence applied on the paintings, it's evident already at the naked eye the chromatic changes turning more darkish, or whitening, or some yellowing, and some paint extraction. With the spectroscopic analysis, it was possible to identify for the tempera paintings a denaturation of the proteic binder because after the irradiation we could see increase in intensity of the band at 7045, which is assigned to a carbonyl functional group of triglycerides, and a slight decrease of the band assigned to the protein. Then for the fresco paintings, it was possible to see an extraction of the surface carbonation layer, as in this case, because after the irradiation we have a decrease of the band assigned to the calcite and an increase of the bands assigned to the pigment. Applying the threshold fluence of the painting on the soiled samples, we had some different effects, as with the fluences lower than 0,2, we have no soiling extraction and no paint damages, so we need to increase the fluence. Then the only one case in which we had the possibility to keep the same fluence was the tempera with Mars red, in which we saw a satisfactory soiling extraction and no paint damage. Then for the other samples, irradiated with fluences higher than 0,3 and 2, when there's a good soiling extraction, but some slight paint damages as color changes or some minimum extraction. And also for the samples irradiated with fluences higher than 2, there's an evident paint extraction even reaching the intonaco. So in the last two cases, it was necessary to decrease the fluence. Adjusting the fluences, we reached a range in which there's a good extraction of soiling and no damage paint. damage for the paintings, and this is range of 0,2 and 0,8 down centimeter quarter. Even in this condition, it's still evident the greater protection given by the binder, especially by egg yolk, in the more susceptible pigments as cinnamars and Mars red, and silicates as Egyptian ultramarine blue and green earth. On the other hand, greater protection is given by the calcite for chromium green and Egyptian blue. From the point of view of colorimetric analysis, all the values of delta A are higher than the threshold value established before, and this could be affected by different cases as soot permanences on the surfaces, lesser effects on the pigment or on the binder, then some increase in roughness, and hypothetically, but still need to be studied, some color changes because of the climatic chamber. From the point of view of the composition of the pigments or the binder of the pigment susceptibility, it's no more evident with the silicates or oxide, but it's still evident with the sulfide, which wasn't possible to consider as suitable for this cleaning tool. For the other samples, contrasted in yellow, it's possible to consider them as suitable, but we need or to reassess the diffluences or to proceed with other techniques. And this, for example, is the case of these 3 samples, as the painting with Mars red and the chromium green in tempera, because there's a great influence of the roughness, which still keep inside the roughnesses the contamination. So it could be better to proceed with other techniques. And about the reassessment of the influences, it's the case of the tempera samples of the blue pigments, because in the ultramarine blue we saw some slightening, so to be more conservative we choose the square with just 1 scan of the laser, and same for the Egyptian blue, in which we saw some slight yellowing in both cases, and this could be depend by slight scattering in a thin absorbent layer, so cinnabar and the film created by the egg yolk, and surface roughness. So to conclude, irradiating the samples with a laser neodymium Yagat 1064, it was possible to identify some pigment susceptibility found in the silicates that are the more resistant to sulfide, which is the more susceptible, and applying the laser on the painting mock-ups, it was identified a protective character given by the binder as egg yolk and calcite, because the influences were higher than the influences applied on the pigments. And to answer to the second question, the application of the damage threshold of the paintings on the artificial soil samples will have some different effects, as no changes, color changes, or painting instruction. And this was depending by the presence of the solid on the surface and the applied fluences. So readjusting the fluences, the fluence necessary for the cleaning in these cases had the range between 0,2 and 0,8 downward centimeter quarter. And so thank you for your attention. Okay.
Thank you to you.
Thank you.
And I don't know if there are questions from the audience. I cannot see. And so I want to ask you something. Thank you very much for your contribution. It was very interesting. I want to ask, at a certain point, I don't remember the slide, but you said when you were talking about the chromatic variation, that perhaps some chromatic variation were due also to the process in the climatic chambers, the aging process in climatic chambers. So it's not clear to me, when you calculate the chromatic differences, you compare the treated sample to test one that was not treated to aging process.
Esatto, sì.
Okay.
We still need to submit some samples without decontamination to the climatic chamber to be sure in the comparing, but still need time to do this.
Okay. So perhaps
it's an hypothesis, but we still need to investigate.
So perhaps there are two different reasons why we have this variation. One due to the aging process, and another one due to the treatment. Yeah.
Yeah, this is the hypothesis, but still no more data to confirm one
Okay,
or two.
it could be a future step of
Yeah,
analysis.
surely.
Okay, okay. Thank
Okay.
you very much.
Thank
Even
you.
because you were perfectly in time.
Thank you.
So if thank you. We have not other questions. We can move on, and the next